Hello students, welcome to my YouTube channel. In this video lecture, we are going to solve questions from sample paper number 3, question 31 to question number 40. In my previous video lectures, I have solved the first 30 questions. I hope you have watched them and you have come down here to watch this video lecture. So let's start with question number 31. Aircraft was over A at 14:35 hours flying direct to B. Distance between them is 2,900 miles. True airspeed is given. Outbound wind component is a tailwind 55. Mean wind component back home is a headwind of 75 knots. Endurance is given to you. What is the distance from departure to point of safe return? So let's draw the diagram. Point A, point B. There is this point of no return between them. You're flying from A to B. Okay. The true airspeed of your aircraft is 470. Outbound wind speed is plus 55. That means going outbound, you are getting a push of a tailwind plus 55. Then coming homebound, you are getting a headwind of minus 75 knots. Minus 75 knots. Okay. TAS is going to remain the same. TAS 470. So what will be the ground speed outbound? Outbound ground speed will be 470 TAS plus 55. So 470 plus 55, 525. Homebound ground speed will be 470 TAS minus 75. So 470 minus 75 is 395 knots. Now we will use our distance to PNR formula, which is endurance into outbound speed into homebound speed divided by outbound plus homebound. So endurance is what? Endurance is 9 hours 30 minutes. Outbound speed 525. Homebound speed 395 divided by 525 plus 395. So 525 plus 395 is 920. So 9.5 into 525 into 395 is equal to 1970062. When divided by 920, that equals to 2141 nautical miles. 2141 nautical miles. So correct answer is option Bravo. Aircraft was over Quebec at 15:45 flying direct to Romeo. Distance between them 3016. TAS given to you. Outbound wind component, flying outbound you are getting a headwind of minus 90 knots. Flying homebound you are getting a tailwind of plus 75. Endurance is given to you. What is the distance from departure to the point of safe return? So again draw Alpha and Bravo, that is your departure destination. Quebec Romeo, PNR. Okay. So now TAS, true airspeed flying outbound equals to 525. True airspeed flying homebound equals to 525. Now component outbound wind component is minus 90. That means you are getting a headwind of minus 90 knots. Flying homebound, you are getting a tailwind of plus 75. You are getting a tailwind of plus 75. So outbound ground speed will be TAS minus headwind. So 525 minus 90 that is equal to 435. Ground speed homebound will be TAS plus 75. 525 plus 75 equals to 600. Distance to PNR equals to endurance into outbound into homebound divided by outbound plus homebound. So endurance is 10 hours into 435 into 600 divided by 435 plus 600 plus 435 is 1035. 10 multiplied by 435 into 600 is 2610. So divided by 1035 equals to 2521.7. So 2522 nautical miles. Okay. So the correct answer is option Bravo. Simple. Next. Distance A to B, outbound speed, homebound speeds are given. The time from point A, departure to the point of equal time is how much? So, distance to critical point equals to total distance between departure and destination multiplied by homebound speed divided by outbound plus homebound. Total distance between them is 2450 multiplied by homebound speed 385 divided by 385 plus 350. So 385 plus 350 is 735. In the numerator you will have 2450 multiplied by 385, 943250. So distance to critical point will be 943250 divided by 735, which is 1283 nautical miles. Time to critical point will be distance to critical point divided by outbound speed. So 1283 nautical miles divided by outbound speed 350 knots. That is equal to 3 hours 40 minutes. 3 hours 40 minutes. 3 hours 40 minutes is equal to nothing but 220 minutes. Okay. So option alpha. Next. At 4 o'clock 30 minutes, aircraft is in level cruise flight. Ground speed 350 knots. Flight level 370. 165 miles away from a VOR. It is required to descend at a mean rate of descent 1800 feet per minute to go down to flight level 80. What is the latest time to commence descent if the ground speed in the descent is 200 knots? So let's draw this diagram. Here you have a VOR station. Okay, here is your aircraft. So you're flying at flight level 370. You're flying at flight level 370. Your level out altitude is flight level 80. How many distance you are? 165 nautical miles away from this VOR station, right? Next, 0430 beginning time, rate of descent 1800 feet per minute. Now, how much descent you have to? How many? How many feet? How many feet you have to descend? 37,000 feet से लेके 8,000 feet. So 37,000 minus 8,000 is 29,000. So you have to descend 29,000 feet. At a rate of descent of 1800 feet per minute, you will take how much time to descend that much 29,000? You will take 16 minutes. You will take 16 minutes to descend 29,000 feet. Right? Next. Now, the ground speed in descent is 200 knots. Ground speed during descent is 200 knots. At this speed and time 16 minutes, you are going to cover a distance. How much distance? 200 into 16 divided by 60. You are going to cover a distance of 53 nautical miles. So out of total distance of 165 nautical miles, out of a total distance of 165 nautical miles, you are going to cover 53 nautical miles. You are going to cover 53 nautical miles during your descent. Okay. So remaining distance will be 165 minus 53, which is 112, which is 112. Right. So let's write it down. 112. Okay, so you will travel 112 nautical miles straight and level. After the end of 112 nautical miles, you will begin your descent. And in this descent, you will cover this remaining distance of 53 nautical miles and you will arrive over the VOR at 8,000 feet. So now the ground speed during cruise is 350 knots. Ground speed in cruise is 350 knots. The distance you have to cover is 112 nautical miles. So the time required to do that will be distance by speed. So 112 divided by 350 is equal to 19 minutes. You will take 19 minutes to cover a distance of 112 miles at a speed of 350 knots. So you are at 4 o'clock 30 minutes here. So 19 minutes plus 4 plus 4 hours 30 minutes is equal to 4 hours 49 minutes. So that means till 4 hours 49 minutes you will travel in cruise. You will spend your flight time in cruise. At 4 hours 49 minutes you will begin your descent. Okay, so what is the latest time to commence descent if the ground speed in descent is so and so? It is Charlie, 4 hours 49 minutes. Next, aeroplane is to depart from an airfield where performance takeoff mass is 89,200. Certified maximum masses are ramp mass so and so, takeoff mass is given, landing mass, zero fuel mass, fuel on board at the time of parking, taxi fuel, trip fuel, contingency reserve, alternate fuels are given, DOM is given, what is traffic load? So simple question. Step 1, step 1, three columns, one for takeoff, the second for landing, and the third for zero fuel mass. Okay. Now the takeoff mass column, you are going to write a quantity which is the lesser of performance limited takeoff mass and structural takeoff mass. So over here, performance takeoff mass is 89,200. Structural takeoff mass is 89,430. So between them, performance takeoff mass is less, 89,200. So we will go ahead with that, 89.2. In the landing mass column, you are going to write a value which is the less of performance limited landing mass and structural limited landing mass. And then you are going to add that to trip fuel. So performance limited landing mass is not given to us. We have only one quantity. Structural landing mass 71,520, 71.52. Trip fuel 17,830, 17.83. So 71.52 plus 17.83 89.35. In the zero fuel mass column, you are going to write zero fuel mass plus fuel on board at the time of takeoff. So zero fuel mass is 62,050. So 62.05 plus fuel on board is trip fuel. So you are going to add trip fuel at the time of takeoff plus contingency reserve and alternate fuel. You are not going to include taxi fuel because by the time you go to your runway, you will have burned all your taxi fuel. So trip fuel is 17,830 and other fuel is 9,030. So 17,830 plus 9,030 is 26,860. So 26.86. 26.86 plus 62.05 is 88.91. Now out of these three takeoff values, you are going to select that takeoff value which is the least of all. So the least of all is 88.91. So now this becomes our regulated takeoff mass. Regulated takeoff mass 88.91. Step 2. Use the formula. Regulated takeoff mass equals to dry operating mass plus fuel on board plus payload. 88.91 equals to DOM, which is 40.97, fuel on board 26.86 plus payload. So payload will be equal to 88.91 minus 40.97 plus 26.86, that is 67.83. That is equal to 21,080. So what is the payload? 21,080. 35 is A. Next. 36. Aeroplane is performance limited to a landing mass of so and so. Dry operating mass, zero fuel mass are given. If the takeoff mass is so and so, the useful load is what? The useful load is what? So always remember, you begin from basic empty mass. Then, so basic empty mass plus variable loads. What are variable loads? Crew baggage, crew, food, water. That gives you dry operating mass. Then dry operating mass plus fuel on board or takeoff fuel gives you operating mass. Dry operating mass plus payload, just the payload, not fuel, gives you zero fuel mass. Then operating mass plus payload gives you takeoff mass. And zero fuel mass plus fuel on board also gives you takeoff mass. Then DOM plus useful load. What is this useful load? It is fuel on board plus payload is nothing but useful load. Okay. If the takeoff mass is so and so, what is the useful load? Useful load is fuel on board plus payload. Fuel on board plus payload. Now we all know the formula. Regulated takeoff mass equals to dry operating mass plus payload plus fuel on board. So in place of payload and fuel on board, we can write regulated takeoff mass equals to DOM plus useful load, and we have to find that out. Now DOM is given to you, regulated takeoff mass. The performance limited landing mass is 54,230. Dry operating mass, zero fuel mass is 52,080, and takeoff mass is 64,280. So 64 regulated takeoff mass is this. DOM is 35,000 kg. So useful load will be 64,280 minus 35,000, which is equal to 29,280. Option Bravo. The empty mass of an aeroplane as given in the schedule is 61,300 kg. The operational items like variable loads is equal to 2,300 kg. If the takeoff mass is 1,32,000 kg, including a usable fuel quantity of 43,800, the useful load is what? So again, useful load is nothing but takeoff mass minus dry operating mass, right? So takeoff mass is given to you. That's fine. Now dry operating mass is what we have to find out. What is dry operating mass? Dry operating mass is basic empty mass plus variable load plus variable load. So basic empty mass is 61,300. Variable loads is 2,300. So dry operating mass will be 61,300 plus 2,300, that is 63,600. Next step, useful load will be takeoff mass minus dry operating mass. So 132,000 minus 63,600 is equal to 68,400 kg. So dry operating mass is 68,400 kg. So 37 is Charlie. Next. Question 38. Dry operating mass, payload, maximum takeoff weight are given to you. Taxi fuel, tank capacity. Find maximum fuel and traffic load that can be carried. So DOM, payload, takeoff weight is given to you. And so now over here find maximum fuel. Maximum fuel will be, maximum fuel that you can carry on board will be your total fuel on board or total tank capacity minus taxi fuel. So that will be equal to 16,100 minus taxi fuel 200, which is 15,900 kg. And with this, we will substitute here 66,200 equals to traffic load plus dry operating mass 33,500 plus fuel on board 15,900. So traffic load, maximum traffic load will be equal to 66,200 minus 33,500 plus 15,900. So that is 49,400. So traffic load will be equal to 16,800 kg. So option alpha. Question 39. The center of gravity location of aeroplane is normally computed along the longitudinal axis. Okay, so let's say this is your aircraft, right? This is your aircraft. There will be a datum in front of your aircraft. It can be inside your aircraft, outside your aircraft. Let's say it is here, outside your aircraft, and this is your datum, and the center of gravity is somewhere here. So all your measurements of center of gravity will be done with respect to this datum longitudinally along the longitudinal axis. What is longitudinal axis? It is the axis passing through the nose and tail of your aircraft. So the correct answer is Bravo. While using a vertical speed indicator, a pilot can not rely on reading, especially when change of pitch attitude is occurring, only rely when changing to horizontal flight, rely on its readings in all attitudes of flight, altitudes of flight. So option A is the correct answer. While using a VSI, you cannot rely on its reading when you are initiating a change in your pitch attitude, climb, descent, straight and level, whatever. Because a vertical speed indicator suffers from lag error. Okay, it suffers from lag error. It will not show you the correct rate of climb or rate of descent instantaneously. It suffers from lag of some 2-3 seconds, and after that lag, after that time gap, it will show you the correct indication. So that's why initially you cannot rely on it. Once you are stabilized in your pitch attitude, climb attitude, descent attitude, straight and level attitude, you can uh, depend on its readings. You can rely on its readings. So this concludes a lecture. I hope you have understood all the 10 questions, all the weight and balance questions especially that I have solved in this video lecture. You can practice more payload questions from Keith Williams' weight and balance book. I have solved all the payload questions from Keith Williams' weight and balance book and already uploaded to my channel. So do watch that video lectures, all the video lectures. There are some 120 questions. So watch those lectures, practice all those 120 payload questions. It will be enough of a practice and your confidence will also increase. Best of luck. Don't miss my next lecture in which I will solve next questions. See you there.